In my previous video, I took years of old video diaries, videos I've been recording since I was a kid, and started turning them into a private, self-hosted memory vault. By the end of part 1, I had the basic infrastructure working. The videos were gathered, cleaned up, renamed, transcribed locally with Whisper, converted into browser playable formats, and viewable in a basic web interface. But at this point, the app was still mostly just an organized video library interface. The whole reason I started this project was because I wanted to ask a bigger question. What if I could actually make a search engine for my life? At this point, I had implemented full-text search across the transcripts, but AI technologies could allow us to do something even cooler. Search by vibes. We can ask questions like, what were my top 3 obsessions in 2019? What themes did I keep coming back to over the years? So in this video, I'll talk about building out the actual AI architecture behind MemoryVault. And speaking of AI architecture, I'd like to take a moment to thank DataCamp for sponsoring this video. If you're looking for a structured way to learn AI engineering, DataCamp offers some excellent hands-on courses. One thing that has been made clear with this project for me is that there is a huge difference between using AI to build the projects and building AI projects. It's one thing to ask an AI chatbot a question, or even just vibe code, but it's a whole other thing to build an app whose features are AI technologies that you implement. If you're in a spot where you can write Python, you're comfortable with basic AI concepts, but there's still a gap between using AI tools and building projects that use AI, that's exactly what DataCamp's Associate AI Engineer tracks are designed to bridge. DataCamp has structured, hands-on learning paths for AI engineering, including their Associate AI Engineer for Developers track. It covers practical skills like working with AI models, building AI applications, understanding embeddings, and creating real AI-powered workflows. And if you're more interested in going a little deeper into model training, evaluation, and data side of AI systems, there's also the Associate AI Engineer for Data Scientists track. What I like is that these are not just random one-off tutorials, they're structured paths that lead toward a certification, and they're focused on practical project-based skills. So if that sounds like something you'd be into, the link for that is in the description. So for a quick recap of what already exists, we can browse videos sorted by date, we can play those videos, we can read and click around on the transcripts, and we even have full text search on all the transcripts. The main goal for this section of the project is now being able to explore the vault semantically, by meaning. Some of the AI features that I explored that I'll be covering in this video were a semantic map of the videos, a semantic search, which then led into being able to chat with the entire vault directly using RAG. And of course, we kept the same initial constraint. It's going to be 100% locally self-hosted and private. So one of the core technologies behind natural language processing is storing language as vectors, or what are known as embeddings. If you've ever taken a physics or calculus class, you may know that vectors are something that can be represented visually, geometrically. In the context of NLP, those embedding vectors, how they are in relation to each other actually has meaning. In fact, that's entirely where their meaning lies. So as a starting point, I thought it'd be interesting to embed every single video and then show how the vectors are related on a visual map. To start, I used this embedding model, which specifically embeds sentences and paragraphs, and creates a 384-dimensional embedding vector for each video. However, it does have a character limit, so for now, we will just use the first several sentences of the transcript. Later, this can be replaced with an LLM-generated summary, which would provide more accurate coverage on the actual video material. So as I mentioned, embeddings turn text into numbers, and similar meanings should end up close together in the vector space. This is what lets the computer compare videos by meaning instead of by exact words. The reason why this is exciting is because it'll allow videos to be grouped by what they are about, and the system can begin to find patterns across years of footage. Now, since vectors can be represented visually, we can turn our list of videos into a visual map. However, if you were paying attention, you may have noticed a problem. If each video embedding has 384 dimensions, how on earth would that look like, since we can only really see 2 or 3 dimensions? The solution to that is to use something known as PCA projection. So PCA projects high-dimensional vectors into lower dimensions, while trying to preserve as much meaningful variation as possible. In this case, we can use it to turn our 384-dimensional vectors into 2 dimensions, into 2D coordinates. Now, as I was researching this is where linear algebra and prop stats concepts from my classes started showing up in a real project, and even though a lot of it was kind of going over my head, I was recognizing some familiar terms like, vector projection, covariance, eigenvectors. So it was kind of a cool moment of class concepts becoming actually practical. So once we have those two coordinates, we can display each video as a point on the map. The idea is that similar videos appear clustered closer together, and each point can show the video title, the date it was taken, a preview of the text, and of course a thumbnail. And then clicking on a point opens a detail where we can go in and watch the video. The purpose of the map is not necessarily perfect accuracy, it's just kind of an introductory way to explore the shape of the archive. Now, once the videos have embeddings, we can now also use them for simple semantic search. The key difference from keyword search is that the system does not need exact words. It can now find videos that are conceptually related to a query. So kind of the flow of how it works is we enter a query, then the query gets embedded the exact same way as the videos did. And then we compare the query vector against video vectors and rank videos by cosine similarity, basically how similar they are mathematically, and then return the closest matches to that query. So the results of this made a stretch of sense, but honestly they were not great. Why? Because of the main shortcut we made, only embedding the first little bit of each video, which moved us into the next phase, chunking. The first version used one embedding per video. This is simple but very limited. One video can contain many topics. Diary entries are messy and often long, so the first bit may not represent the whole video. Important moments later in the video may be missed. A 40-minute long video may talk about school, friends, family, emotions, random stories, and even if search returns the right video, it might not return the exact moment that we want to find. And this moves us into the next architecture step, which is time-stamped transcript chunks. So instead of one embedding vector per video, we split the transcript up into chunks of approximately 60 seconds with some overlap, and then have one embedding vector per each of those chunks. Each chunk will store the ID of the video, starting and an ending timestamp, the transcript text of that segment, and then the embedding model we used just for tracking, and then, of course, the embedded vector itself. The benefit of this is now the search can actually return exact moments in the video, and we can jump directly to the relevant timestamp. And this is also a much better foundation for RAG, which is how we're going to get our AI to cite its sources. Which brings us into our next phase, building out the actual RAG system. So RAG stands for Retrieval Augmented Generation. Basically, instead of just asking an AI model a question and expecting it to pull an answer from its training data, we first retrieve relevant pieces of your own data. Then give those pieces to an AI model as context, and the model answers using that context. So for MemoryVault, this looks like us asking a question, that question getting embedded into a vector, exact same as the chunks, and then the app searches which transcript chunks are most similar to our question. Relevant chunks are passed to a local LLM, along with its prompt, and then the LLM takes those chunks as context and generates an answer. And the answer is able to include source video citations with timestamps. And of course that moves us into finally adding an actual LLM into the app. So for this, I hosted a local Ollama model, but I actually didn't run this on the same server as the rest of the app. As I mentioned in the previous video, I'm running the backend and the front end on a Linux server. However, that one does not have enough RAM, GPU, or anything to run a decent AI model very efficiently. But what I do have is an old M1 Mac Mini, also discarded from the IT office where I work. So I hosted Ollama separately on that, and then had my backend connect to it through the local network. So this LLM's job is simply to interpret received transcript chunks. And the way we make sure this happens is through a little bit of prompt engineering. We tell it to answer only from provided excerpts, to cite timestamps, not to invent details, surprisingly this works, and just say when the evidence is insufficient. The reason why this matters particularly is because this is personal diary data, so hallucinations would make the app feel particularly unhelpful, and grounding and citations are essential. One example question I tried was, what were some of the business ideas and ventures I had? So now what it does is it finds the 5 most relevant transcript chunks, pulls them, into the context and then synthesizes a plain language response based on that context. I'm thinking that 5 chunks may not be enough for the more interesting questions I'd want to ask, but as a starting point, this is already pretty good. So I thought this whole project could be covered by these 2 videos that I plan to make. Honestly, I probably should have known better because there is always room to add more to any project. So for example, currently the transcript search only captures what is said, but some videos may contain things that were never spoken aloud. In the future, we could add a visual search layer by using multimodal embeddings. So instead of just embedding text, we could also embed images and video alongside it. This would provide much better context for videos that aren't strictly video diaries and aren't very well narrated. Along with that, we could also improve our transcription pipeline because our AI system will only be as good as our data. I didn't mention this, but I also upgraded from Whisper to WhisperX since the first video, and that did start getting me much better results with the transcription. However, it's still nowhere near as good as some of the commercial tools that I use for voice dictation, so I know the technology is there. It's just a matter of finding the right tools and lots of tweaking. So that's kind of where MemoryVault is at right now. On top of the organized, transcribed, searchable library we built in part 1, we now have a system that actually understands meaning with semantic search, a visual map, granular results that jump to the exact moment in a video, and a local RAG pipeline that lets me ask natural language questions about years of my own footage. One thing this project reminded me is just how interesting looking through my past actually is. I had hours of videos from when I was a teenager that I basically never watched because finding something specific was just way too time consuming. And now I can breeze through it. There's still a lot I want to add, so there might be a part 3 eventually, but for now I'm pretty happy with where it landed. I will link my full GitHub repo, minus the actual videos, in case you would want to check it out in more detail. And again, thanks to DataCamp for sponsoring this video. As a reminder, their AI engineering courses are linked in the description. If you made it this far and you're new, I'm a computer science student sharing my journey to becoming a software engineer here on this channel, and just building cool stuff. So if that's interesting to you, feel free to subscribe and stick around.